Our next talk, we are having Rediet Abebe on, who is going to talk about modeling the impact of shocks on poverty.
Abebe.
Sorry.
Good. Very good. Max, come on. Good. Thank you, Max and Binta and everyone else who's here for organizing and attending. I know Zoom world is getting to be a bit exhausting, but I appreciate you all for being here. So I'm going to talk to you all about one line of work, but two papers here. One of which was sort of completed about a year ago, and another one which is sort of ongoing, although we have some insights here that I'm really excited about. And they're both related to questions around poverty. So as you know, the poverty is a problem that's very highly prevalent across the world, including here in the United States where I'm based. So for instance, in the San Francisco Bay Area, we know that something like a fifth of the population lives in poverty by some measurements of poverty. And despite its prevalence, a fifth of, a giant city in the U.S. and really the country, despite its prevalence, we know that poverty is really, really difficult to measure, right? And so often what we do is we rely on very simple measurements of welfare, like we use people's income or their wealth, or maybe even more coarse measurements, and we use those to make decisions, really consequential decisions about what resources families are going to get. But at the same time, there's a really large body of empirical and policy work that shows that these measurements are totally insufficient. So there's this study that I really like called the Poverty Tracker Study by the Columbia Population Research Center, which says that official income only measurements of poverty were very optimistic. They painted an optimistic picture and they didn't fully capture the magnitude of disadvantage that New Yorkers were facing. So this is a study that's based in New York City. And really, this issue of measurement, right, a measurement of welfare and disadvantage is a really complicated one. So, for instance, if you have run into this book, Social Stratification, it's a giant textbook that that we went through as part of my graduate inequality class in sociology back in whenever 2016 I think is when I took it. In the first page, this table one of the book, it shows you this table of different forms of advantage or disadvantage, right? So you could have these like asset groups: economic, cultural, social, physical, human, and under those you have these examples, right? So under economic, you would have wealth and income and ownership. Under social, you'd have social clubs, workplace associates, informal networks, and so on, right? And so there's this very deep awareness within the social sciences that disadvantage is multifaceted, it's multidimensional, it's very complex. And often what we end up doing is we pick, a couple of things, maybe even one thing, and we use that as a sort of proxy for the advantage or disadvantage that families are facing. And I won't get into this, but I do want to hint at it. This is one of my favorite articles. There's an essay that's by David Grusky, who's the editor of the book that I mentioned, and Kim Whedon, who's a mentor of mine in sociology at Cornell. They wrote this piece called "Do Disciplinary Boundaries Keep Us from Asking the Right Questions About Inequality?" And they're really tackling this question of this multidimensional nature of poverty, of disadvantage and inequality, and how different fields might be taking, one or two variables as being sort of their kind of implicit bet about what they think best approximates welfare, but really you might still be missing something, right? And so what is one of the things that we're missing that we can kind of like try to grapple with as we kind of think about how to measure poverty? One of the missing dimensions is income shocks. So we've seen that income shocks play a significant role in leading to cycles of disadvantage. So one of the kind of more popular examples now is how income shocks might be contributing to people not being able to pay their rent, and as a result experiencing housing instability, right? So there's work by Matt Desmond, a sociologist at Princeton, that shows that these kind of income shocks can play a really instrumental role in experiences of eviction by individuals like R.S. Sparkman, who's the woman that you see pictured here. This picture was taken the day that she was evicted from her home in Milwaukee, right? And so these income shocks, they're not kind of gaining popularity, but the role of income shocks has been studied for quite some time especially in economics and in sociology. We know that they play a significant role in housing and in health and in education. They've been studied extensively in economics and household consumption dynamics, and also in optimal taxation theory, right? So there's this really rich body of social scientific work, both empirical and sort of more conceptual, to try to understand shocks as kind of one dimension of disadvantage that families might be facing. And so the question that we tackle in sort of this body of work that I want to mention to you is how there's this awareness that disadvantage is multidimensional, but often we make decisions using just one thing, right? Often using just sort of income or wealth or something else that's even more coarse. But as computer scientists, we know that there's the kind of potential and the ability to combine different dimensions, right? Even maybe sort of less well studied ones, or ones that have not been incorporated into measurements of welfare, like income shocks, and maybe use that to actually make some sort of progress or improve our understanding of how to best target and how to best assist families that are experiencing disadvantage. And so the question that we looked at is, how can we design algorithms that optimally allocate subsidies when agents are experiencing income shocks? Okay, so we're going to say, usually when we think about subsidy allocation, we just look at people's income or maybe their wealth, and we make a decision about who we're going to assist. But here we're going to kind of challenge ourselves to extend a little bit more and incorporate measurements of income shocks into our measurement of welfare, and use that to see how that might change optimal allocation of subsidies. So the model that we work here is a kind of very stylized one. So we're going to build up to it. You can picture here, you have n families, and on the x-axis you have time, and on the y-axis you have a reserve, which is sort of like a kind of a measurement of how well the families might be doing. We're going to assume that time runs continuously, and each agent has an initial reserve or wealth of U sub I, and a net income of C sub I. So this net income you can think of as kind of on average what that family would be earning minus on average how much they would be spending. So this is what they would sort of have left over at each time period, and that's just going to go into their reserve. And so at time t, the family's reserve is kind of straightforward, right? It's just what their reserve is in the beginning, which is their wealth, this U sub I, and then you're multiplying the net income C sub I by t, and that's just what the reserve is at time t. Right? So a very simple, very stylized situation that we're looking at here. But now we want to incorporate shocks that families are experiencing. So we'll model these as sort of sudden drops in these reserves that families are experiencing. And we'll assume that these shocks are arriving as sort of randomly selected discrete points, t sub 1, t sub 2, and so on. And we'll assume also that these shocks arrive according to a Poisson process with arrival rate beta sub I, right? So these things are indexed by the I because, different families can have different arrival rates. They can have different income, they can have different initial wealth, and so on, right? And so you have these shocks that are arriving at these discrete points in time, and you have this parameter beta sub I that measures the frequency with which the families might be experiencing these shocks, right? So you have this Poisson process. And we also assume that once the shock arrives, then we are going to draw the size of the shock from some distribution f sub I, right? Again, this can be different for different families. And so what you're doing here is once the shock arrives, you draw from this distribution f sub I what the magnitude will be, and you're just going to subtract that from the family's reserve. And so now the reserve, again, is not much different, right? It's kind of straightforward to see where I'm going with this. Basically, now the reserve at time t with shocks is what the reserve would have been if that family had not experienced any shocks, minus the total magnitude of shocks that the family has experienced up until that point. Right. So now you just have this kind of reserve that is kind of steadily going up, except when the shocks happen, it kind of drops and it just kind of keeps going that way. So I just want to pause here because I know I went through that very quickly. Are there any questions? Is the model kind of clear? Okay, I'm going to assume yes, but do unmute yourself and jump in, or maybe chat if you have some questions. So okay, so now you have this model of welfare, but this is where kind of the fun starts, right? So basically, we're imagining here that kind of inspired by the eviction literature, we're imagining here that um, once the family's reserve falls below a certain threshold, now they become incredibly susceptible to a bunch of undesirable things. For instance, eviction, as I said, or poor health or job loss, right? So this is kind of inspired by the empirical work. We're assuming that after a certain point, if you've fallen below this threshold, you've experienced ruin, and a bunch of things are going to happen that we think are completely undesirable for and kind of painful for families to go through, right? And so our objective interest now becomes this ruin probability, right? The probability that at any time point you have fallen below this threshold that will set to be at zero, right? So the probability that you've experienced ruin. And so this object of interest is now, is now kind of, we can write this down, right? So this object of interest is this ruin probability psi sub, which we'll denote by psi sub I. It's a function of what the family's income is, what their initial wealth is, the arrival rate, the beta sub I from the previous slide, and the distribution from which the shock sizes are drawn, right? So you now have this kind of this function here that you can look at that allows you to kind of capture all the different things that were going on. And so as a planner, you're giving out subsidies. Let's start with sort of an income subsidy, right? A pretty straightforward subsidy that we can think of, where we're saying that I have a budget B as a planner, and I'm giving out income subsidies X sub I to families I without violating the budget constraint, right? So the sum of the X sub I has to be at most my budget B or less. And as a planner, I also have the opportunity to decide what I'm going to optimize for. So we'll pick one thing, we'll change this later. We'll imagine here that I'm optimizing for a min sum objective, which says that I want to minimize the expected number of people that experience ruin, or just stated here, I'm just trying to minimize the sum of the ruin probabilities, right? So great. So now we have this kind of very clear optimization problem, right? You have your object of interest, which is the ruin probability. We have an intervention, which is an income subsidy. We'll change that later, but we'll start with that. We have a sort of an objective, which is a min sum objective. Also, we'll consider a different one later, but let's just start with that, right? And so I have this, and now I can ask, a very kind of straightforward optimization problem, which is how can I optimally allocate these income subsidies? But yeah, go ahead.
A clarifying question that might be interesting to ask now. So Jesse is asking, I can't tell if it's just this example, but the reserves always increasing linearly with the space.
Yes. Yes, great question, Jesse. So, so there's two things that I heard from your question actually. So one is like this is just kind of going up, right? This is increasing. So, in the examples that we consider in the next few slides, we'll assume that families have positive drift, meaning that on average they're just kind of going up, right? So that's an assumption that we make in the beginning. We'll drop that later. And then the second one is this sort of linearity idea that you mentioned. And yes, we do assume that we just do assume this linearity. We assume that the reserve is independent of the kind of the shocks, right? Like in the sense that once you experience a shock, you don't have the net income changing or anything like that, right? So this is a very stylized model. Yeah, I hope I answered that question. Was that sufficient, or can I clarify more?
It seems like it was sufficient. Thank you.
Okay, very good. Yeah, please feel free to jump in with other questions, but thanks for the question. Good. So we have this optimization problem. Great. So now we're going to start with a sort of very simple, a very stylized kind of simple case here. Which is the case of no initial wealth, right? So we imagine here that the families are starting right at that threshold of zero, but they have like positive net income, right? So we're going to make a couple of different assumptions. So we assume, like I just mentioned, that you have positive drift, meaning that if the f sub I has mean mu sub I, then this positive drift assumption says that your net income minus beta sub I times mu sub I is positive. So just sort of in expectation, you're kind of going up, right? So what that means is that your ruin probability is strictly less than 1, because if you have negative drift, then with probability 1, you're going to experience ruin. We assume positive drift, so we don't have that issue in this case. We also imagine that this distribution F sub I has finite mean and variance on the shocks. And so by making that assumption, we're able to use a pretty kind of remarkable result, I think, from probability theory, which is that the room probability in this situation can be expressed using this very simple expression, right? So it just says, you know, in the numerator, you have the kind of average, the expected shock size that you have, and then in the denominator, you have the net income, right? So you have this assumption, you have these assumptions that allows you to kind of leverage a pretty cool result, I think, from probability theory about what the room probabilities would be. And so under these assumptions, we're now able to kind of go back to our optimization question, which is that we're trying to minimize the expected number of people experiencing ruin, right? And so we can rewrite the sum of the ruin probabilities using this expression that we saw from the previous slide, right? You see the beta sub I times mu sub I in the numerator, and the C sub I plus X sub I in the denominator. We're giving out income subsidies, which is where the X sub I comes in. And in this situation now, your goal here is to minimize this function phi, right? And you want to do that by optimally spending our income subsidy. So we'll look at the partial derivatives of this function phi with respect to the X sub I, and we get this expression that you see here. And we can see actually that this phi is strictly convex, since when we take the second derivative, we find that it's always positive. And so what this says is that a kind of a very straightforward greedy water filling algorithm that kind of orders the agents by this partial value is something that gives us the optimal solution. And the way that this algorithm will go is by saying that I'll first order the agents such that, you know, the first agent has the kind of the large, or I guess the sort of the most negative partial value that you see here, and the second agent has the second most negative, and so on. You keep going, right? And so you order the agents in this way, and then you now give out income subsidies first by you target the first agent and you increase their X sub I up until the point where their partial value matches that of agent 2. Then you assist agents 1 and 2 together up until the point where their partial value matches that of agent 3, and so on. And so you just kind of keep going in this water filling kind of procedure, and either you end up assisting everyone, or in this case, you end up running out of a budget, right? And so, you know, this is a pretty straightforward kind of solution here, but there's something that's really cool about this, which is that it's not just that we have this optimal solution, it's that this optimal solution is kind of given to you by this partial value. It says this is the order in which you should be targeting agents, and that's going to give you the optimal solution, at least in this particular case that we're considering, right? So we have this priority index. And we were sort of curious about this, right? We looked at this priority index. It's not just people's income. It has all these other different things. And so it's very natural to ask here, okay, if you have this different priority index for this optimal solution, how much different can that be from a version of this problem where you're only using people's income, right? In particular, yeah, go ahead.
A quick clarification question. So this is basically you're ordering them by their net income, right? Or is it wrong?
No,
you
that's
have like you have income and the expected shocks per period.
That's right. Yeah, that's exactly. Yeah. So the expected shock per period is the numerator and the net income is the denominator. Yeah, right. Oh, actually, no, that's not true. Sorry. The expected shock is the numerator, and then C sub I squared is in the denominator, right? Max, do you agree?
Yeah.
Okay, good. Very good. Yeah, I can't really see people, so I'm like guessing. Yeah, okay, so but that's an excellent question, right? Which is, I mean, this is precisely the question we were also concerned with, which is, okay, you know, we have this thing, how different is that from just if you order people by their net income? You just went from the person who has the lowest income to the highest income, right? So very natural question to ask. And what we find here is that I can give you a very simple example. You can write this down quickly. That says that actually it can be total reverses of one another. So in this example, you have net income being 1 plus I times epsilon, right, where I is indexing the agents. And so agent 1 has the smallest net income and agent n has the highest net income. But if you were to just kind of plug these values into the previous slide that we saw, then actually the ordering would be the reverse of one another, right? And so that's, kind of surprising. That was kind of surprising to me. And it sort of reminded us of this kind of quote that we saw earlier from the poverty tracker study, which said that if you're only relying on income, maybe you're being a little bit too optimistic, right? Maybe there are people who don't look so vulnerable if you're only looking at their income, but actually are experiencing a significant amount of disadvantage. And so that was sort of one surprising thing. But the second surprising thing that we saw was that we had mentioned that we were looking at a min-sum objective, right? We're trying to minimize the sum of the ruin probabilities, but you can instead consider a min-max objective where you're trying to minimize the maximum ruin probability that you see, right? Totally reasonable objective to be looking at. And in that situation, also, the solution looks very similar, right? You have a sort of priority index that allows you to kind of go in this greedy water filling algorithm way, and you have your optimal solution for this particular case that I mentioned, right? So all wonderful. But again, you can ask, okay, how different can the priority indexes be? And it turns out, again, the exact same example I showed you earlier can give you the fully reversed priority orderings, right? So here, the thing that's surprising is that both the min-sum and the min-max objectives, right? When we're solving both of these, we're taking into account all the same parameters, right? It's not like the first case where one side had all this information about shocks and the other side only had information about income, and then you were comparing these two. Here, both of these optimization problems are solved using the same kind of information, right? And they have a very similar structure to the solution, but it actually is telling you that in one case, it tells you to go this way, and in the other case, it actually tells you to go that way, depending on what you're optimizing for, right? So slightly more surprising. And the third one, and I think you'll see where I'm going with this, the third one that was, I think, maybe the most surprising to me was the intervention itself. And in particular, we had said we're giving out these income subsidies that are kind of, you can think of them as like a month-to-month payment that you're giving to people. But instead, you could imagine that you show up once, you give people a well subsidy, and then you just sort of walk away, like a one-time upfront subsidy, and you walk away. And in that situation, fixing for all these four parameters, you have the same information. You fix for the objective function, right? So the min-sum objective, but you just change the intervention. And surprisingly, again, this tells you that maybe you should be doing the exact opposite. So there might be situations where even when you're optimizing for the same thing, if you're giving out a one-time upfront subsidy, you might be actually wanting to kind of support a different set of people than if you were giving out these sort of like month-to-month type income subsidies. Right. And so I want to pause here and try to appreciate these points, right? We're working with this very stylized model, and yet we still have these kind of very, to me, very surprising results that tell us that, one, the information we're taking in about families really matters. Two, the objective functions, even two objective functions that seem very reasonable, can actually yield very different results. So they really matter. And three, the intervention type matters. And the reason why I kind of want to just pause here for a second and consider these is because, I spend a lot of time talking to folks who are policymakers, social workers, people working in nonprofit organizations, just, you name it, right? Different people in this space. And what I've noticed is that a lot of times we say vague things that are very hard to disagree with, right? Like we say things like, we want to help the most number of people from experiencing eviction and things like that, right? So these are not things that anyone reasonable would disagree with. But the reality is that you have to be very precise about what you mean by help, right? Because the intervention types really matter. You have to be precise about what you mean by the most number of people. Do you mean that, an expectation you're trying to increase something, or are you trying to like kind of lift the floor using a min-max type objective, or something else entirely, right? And oftentimes what happens is that this process of translating these more vague policy objectives into a concrete intervention ends up having some sort of gap, right? At least sort of as a computer scientist, I see a sort of gap. And a lot of things just kind of fall through the cracks there. And unfortunately, these things that are falling through the cracks, at least even in this very stylized setting, are actually very consequential. And so it's important to kind of keep that in mind, I think, in the work that we're doing here. So, having said that, I do want to get back to sort of the more fun math that kept going on after just considering this special case, right? We were looking at the case where agents had zero initial wealth. We get back to a much more general case. We imagine that people can have arbitrary income and wealth. The shocks can be drawn from a general distribution. In fact, we don't even assume that this shock has a shock distribution has a compact representation. It can just be given to you in a sort of black box fashion. And we dropped the assumption that you have positive drift. So now you're allowed to have negative drift. So you can have some families who are an expectation, an expectation just kind of going down. So they have a ruin probability of 1. So the math here gets harder, right? Because you lose convexity that we were able to use earlier that made our lives a lot easier. And the optimization problems that we're looking at end up being NP hard, unsurprisingly. And the reason why this happens is because imagine here that you have this income subsidy that you're giving out on the x-axis and the ruin probability on the y-axis. So if you have a family that has ruin probability of 1, right? So they have negative drift, this ruin probability is 1. What happens is that for a while, when you're giving them income subsidies, their drift becomes less negative, but their ruin probability stays 1, right? So you still have this like kind of horizontal line because their ruin probability is not yet responsive to the income subsidy that you're giving out. It's only when the sort of drift breaks even at this point that you see here that this kind of changes, right? So once the ruin probability starts being less than 1, then as you give out income subsidies, you also see that responding to the ruin probability and the sort of the convexity here returns, right? But before then you don't have that, and it's too bad because that makes our optimization problems that we're looking at NP hard. But we find here that even in this very challenging situation under these like very general assumptions, we find here that we can get pretty close to an optimal solution, which is that we can give a fully polynomial time approximation scheme to optimize for this problem. So for the non-computer scientists here, basically what this means is that you're getting within epsilon of the optimal solution, essentially. So this is kind of under the assumptions that we're making, which are pretty general, right? We're assuming that the shocks can be drawn from a totally random general distribution that I couldn't even, give you a compact representation, and yet we're able to get to a solution that's pretty close to optimal. So this was sort of like best case scenario that we could have hoped for. And I won't go through the proof because there's a few things that I want to mention, but this was sort of like part of the theoretical work that we were doing. But we were also interested in actually kind of looking at how shocks play out in actual data sets and people's lives, right? So far, we were looking at this modeling question. We wanted to understand how we can incorporate this additional dimension of disadvantage into measurements of welfare, but we also just want to see how it plays out in data. And so this is kind of almost done ongoing work, but it's definitely ongoing work. What we did was we reached out to the poverty tracker folks who were doing really incredible work, I think, and they'd been measuring different shocks that people are experiencing over a period of 3 years. So different financial shocks, relationship shocks, accidents and illnesses, crime, arrest, medical shocks, things like that, right? So they've been measuring these for a group of families, over 2,000 families in New York City for a period of 3 years. And they have this really incredibly rich data set, I think, that has these annual surveys that measure official poverty status, material hardship, health, right, sort of big measurements of welfare. And then they have these interim surveys that measure different shocks that people are experiencing. So they look at 10 different types of shocks, actually maybe even more, have you lost public benefits? Have you experienced a relationship that ended? Things like that, right? So they look at like a set of really common shocks that families might be experiencing. And so, of course, as a computational machine learning person, the first question that comes to mind for me is, great, we have this really awesome data set. We know that people have shocks, and we can look at what shocks they're experiencing. Can we use that to predict poverty status, a year out, right? The official poverty status a year out. And if so, do we do better for some groups of people than for others, right? This is kind of like the knee-jerk question that you would ask here. But unfortunately, or maybe fortunately for the purpose of our kind of research, there's a kind of a really strong negative result here, which is that predicting life outcomes is really, really hard. So there's this PNAS paper, it's a very recent paper by Matt Solganic and others. It's got a bunch of different authors that shows that, so they used this data set called the Fragile Families data set that you all may be aware of, and they were able to essentially run a competition, right? So they had a set of machine learning data science groups, like about 150 of them, that each were trying to, predict these different life outcomes like eviction, job loss, and layoffs and things like that. And then they had, on the other hand, sort of domain experts that picked just a handful of features and they just ran logistic regression, right? So they had this data set, longitudinal data set. On the one hand, you have a team of 150 different types of, you have 150 different teams of machine learning people using state-of-the-art methods using thousands of features if they wanted, just like, they have total free reign. And then on the other hand, you have someone who's like a domain expert in the space, like a social worker, let's say, who is given a handful of features that they get to select, and they run logistic regression. And what they found was that the second team does as well and often better than the kind of the first set of people, right, which are machine learning experts trying to predict poverty and these other different types of life outcomes. And so I really appreciate this paper because I think this is a paper that makes a very strong, brings about a very strong evidence for something that I think we'd all kind of experienced. Those of us who work with this kind of data had experienced, which is that predicting life outcomes is this is not where we're going to shine. This is not, where we're the most useful. And so we, of course, find this in our poverty tracker data set too. Basically, we find that if you just threw in all the data that we had available, our prediction accuracy is about the same as if we just used people's income, right? So, there's some richness in the data, but, using prediction is not the way to kind of uncover that richness and to get qualitative insights that might be useful here. And so we kind of rephrase our question here. We instead ask, what if we were, instead of trying to get at this kind of like raw prediction accuracy type approach, what if we were to step back and say, this is still a really cool data set. What qualitative insights can we gather that might still be useful for poverty alleviation efforts? And so this is sort of how we got to this idea of using prediction as a means to an end rather than an end itself, right? And so the kind of recipe that we used here was you still set up the formal prediction task, right? This like, we want to predict official poverty status. But rather than looking at things in a very absolute way, what we instead looked at was the role of different sources of information, right? For instance, if I use just shocks versus just income versus everything else, how does that fare? And you can sort of see here that, for instance, shocks seem to, just using information about shocks seems to give you about the same information as using everything that you have at your disposal, right? So already it says that, like, just having binary information about shocks that you're experiencing is already telling me something, right? So you have this prediction task, you kind of try to understand the role of different sources of information, and you try to understand the role of shocks in a more comparative rather than absolute way. So one way to do that, for instance, might be you say that, I'm trying to predict official poverty status, but I'm going to disaggregate the population by gender or their kind of reported gender. So here the blue is male, the orange is female, and green is all, and it's looking at relative feature importance of these different shocks, right? So you have, you can see here that for female respondents, shocks related to financial experiences like income decrease, major expenses, benefit decrease, and then also relationship endings seem to play a very significant role. Whereas for male respondents, you can see that shocks related to police stop, crime loss, being a victim of a crime seem to play a pretty big role, right? And so, so already here it says these types of shocks might be more relevant to some groups of people than for others. And then among the entire population, benefit decrease and being stopped by the police were sort of the two most important shocks as measured by their ability to help their ability to help you predict poverty. And so that's kind of helpful, but we kind of like actually really wanted to get into the data. And one thing that we did here was we wanted to understand sort of relationships that shocks have with one another. And so, for instance, imagine the following a setup where you have loss of benefits, and you look at only families that experience loss of benefits 3 months into this study, right? So we only look at that set of people that you've lost benefits 3 months into the study, and now we want to understand what does that mean for you in terms of loss of benefits 6 months in or 9 months in, right? And here what we find is that if you've reported losing benefits 3 months in, you're now 5 times more likely to report losing benefits 6 months into the study, 4 times more likely to report losing benefits 9 months into the study, right? So there seems to be a pretty strong relationship between what people are reporting in terms of losing benefits. So you're kind of fixing for the same shock, so maybe this is not super surprising. But actually, we find that there's other shocks that show relationships. So if you've reported losing benefits 3 months in, then you're now 70% more likely to report having a major expense 6 months in, and 50% more likely to report having major expenses 9 months into the study, right? So already there's a sort of amplifying effect that you're seeing here. And that kind of, that relationship seems to be quite strong across a bunch of different types of shocks. And in particular, here, like I think loss of benefits and relationship ending was a pretty strong relationship, right? So you now have 3 months in the study, you lose benefits. 6 months in, you're now 2.3 times more likely to report a relationship ending, and that drops to only 1.8 9 months into the study, right? So pretty robust relationship. So we looked at, co-occurrence of shocks, sequences of shocks, and things like that to try to gain better insights into the relationship that these shocks are kind of having with one another. And so there's a lot of work that we're doing here. I won't go into it in the interest of time because I think we're almost out of time here. But there's a lot of feel free to reach out to me. There's a lot of sort of both more modeling and theoretical based work, but also a lot of empirical work that we're doing that helps us kind of better understand this multidimensional space that is disadvantaged, right? And how we can sort of get better measurements and insights into how we can intervene to better assist families. And I'll close on a kind of a note of gratitude, honestly, for this working group that I've been a part of on inequality through MD4SG. It's led by Chika Okafor, Sarah Lenardi, and Sam Taggart, who are really wonderful people. And the first two are economists, and Sam is a computer scientist, and Max is a member of this working group. And I've been part of this working group for I don't know, like since fall 2018, whenever that was. The concept of time is a little bit fuzzy. And this working group has been doing a lot of exploring of this interface of computer science and economics, and also sociology to some extent, to try to understand what are some new types of questions that we can look at here to better understand inequality, and ask kind of more innovative questions than we would be able to kind of siloed into our own, only into our own disciplines. And this working group is part of a broader initiative that I've had the pleasure of leading with some really wonderful people that you see here: Irene Lowe, Ana Stoica, Francisco Marmolejo, who's at Oxford, and Wan Yi Li. And this initiative is, it's pretty large at this point. It's got actually, it's over 150 institutions in 50 different countries. We have a workshop. We've had a workshop series. We have an online colloquium series where we've had some really amazing people share their work with us. We have these working groups that I mentioned to you. Yeah, this is like, sample of our colloquium series that we've had. And pretty excitingly, I think we have a conference coming up. So our initial workshop series that I've mentioned to you has now matured into an ACM conference called Equity and Access in Algorithms, Mechanisms, and Optimization, EAAMO, or pronounced EMO. I'm very proud of this. And this is a conference that is meant to kind of capture this like nexus of computer science, economics, sociology, public policy, right? Questions that impact marginalized groups and communities, and how these types of tools that we've been talking about could be useful in kind of moving the needle in that space. And I recommend that you go check out the website because we have a lot of really different types of submissions that we accept: data set submissions, problem pitches, position papers, survey papers, demos, but also, of course, all the sort of traditional research submissions as well. And it's there's a non-archival option. Even if a paper has been published in the past year, you can still submit it. So definitely go check it out. And we hope to see you there. It's on October 5th, and submission deadline is June 3rd. So we hope to see you. We hope to see your submissions on June 3rd, and we hope to see you on October 5th. And Max Casey is actually part of the executive committee, so I don't feel so bad mentioning this conference at his conference. And with that, I'll stop. Feel free to reach out if you have any thoughts or questions, and we may have a few minutes here for some discussion as well. Thank you.
Thank you a lot, Rediet. Any questions from the panel or the audience?
Hi, thank you for the talk. Great to see you. So I was curious. So the measuring income. This is I totally get that this is not sort of necessarily a full concept of how we want to measure welfare in the human condition. But I guess I was interested in how you were thinking about shocks, because in some ways what you're trying to get at there is precarity. And I was wondering if you've either been thinking about sort of proposing specific measures of precarity, or if you think this would be a way to sort of measure that as just sort of like another qualitative dimension, which we know is an issue and we talked about with future work, we know is going on.
Yeah, no, that's a great question. So yeah, so it is, I mean, this was like on the path to measuring precarity. So really what we were interested in was like, well, I mean, the first thing we were worried about was just like, if you have this additional thing that you know matters, is there even a way for us to incorporate that in a responsible way, but in a way that's also like mathematically tractable, and we think we actually have the data for it potentially, right? There are all these questions that are a big, kind of question mark, right? Because it's not true of every, like the table that I showed, right, where it had like, workplace associates and social clubs and all these things, like some of those are much harder to find than this thing that we were looking at. So that was really like a proof of concept. We wanted to see if we were able to include that. But something that happened actually very recently was that so I got in touch with someone from USAID got in touch with me, and they were like, let me tell you about all this cool work that's happening in Ethiopia, your home country. Maybe you didn't know, right? And I actually didn't know. So it was really awesome. They were telling me about this like giant assistance program. It's like one of the largest in the continent it's taking place in Ethiopia. And they were talking about precarity and resilience, right? And how these measurements are incredibly, incredibly important in the kind of the global sort of the global development space. And so we're now moving in that direction of being like, okay, now we've kind of played with shocks a little bit. We have some sense of what we might be able to add, but really what we want to get to is precarity and resilience, and how do we better measure that? And so I hope in about a year I'll have better answers for you, but I think your question was like exactly the right one, which is that yes, that's the direction we want to move in. Yeah.
I'm happy to, I guess I never know if we're going from the panelists or not. I really enjoyed the talk. I had one thought I was thinking about this point of, you had a bunch of things you're doing, but one of the things that shows up in some of the stuff I've been thinking about, like related to welfare programs. So what comes up there is, so say like food stamps or, whatever you want to call it, or I would do a lot of work in consumer bankruptcy. There's this question of TakeUp or UI or health insurance, like Medicaid. And so
Right.
I've been so this like prediction problem that's interesting from like from thinking about who to target is like, who are the people who need to receive the whatever it is. But then I was curious if you have thoughts about this prediction of take-up. And one of the reasons it comes up is because like the way that in the design of this, there's this idea of like hassle costs to try and screen people and stuff like that. So I'm curious if like, I know you're coming from a very different perspective, but in terms of thinking about take-up, like, is that something you guys have trying to do prediction on? It seems like a really valuable, especially in like, for example, the Medicaid space, that seems really valuable.
Yeah, no. So yes, actually so I actually have a call right after this one ends with folks at Benefits Data Trust who are working on exactly this problem, right? So they're curious about why people who are eligible for public benefits in the US are not taking advantage of them. And some of it is like, some people don't take advantage of it because if they do, it jeopardizes their immigration status. Right. Mm-hmm. Or right. And this is not one of those things that's like, oh, if only I just change the UI a little bit, then maybe you'd apply. No, you're not applying for a very rational reason. Right. And so some of it is things like that. Often it's that they don't know, or there's just so many barriers. I mean, my God, like I knew this was the case, but I talked to a bunch of social workers to get a sense, and this is impossible. It's like we've set things up in a way where we're like, we really don't want you to take advantage of this resource. We just want to say that it's there. Like that is the only rational explanation, right? So there's that. So Benefits Data Trust and some other folks are working on unifying eligibility, right? So you don't have to like apply for every single thing. So we're talking to them. It's the beginning stages, but we're looking at just like, how can we like leverage community structures to kind of disseminate information to amplify that? I don't know where it's going to get. What's that?
So no, the only thought I was going to have is just it was provocative in the first part of your talk where you were thinking about income and the way that you can measure things differently, is that in this this literature about like what you're doing is you're trying to keep people from who are high income. This is like these hassle costs. They're trying to screen people. But so I think what would be interesting in the way that you're saying it is you're making this point of like, those who benefit from it, in some ways it doesn't even have to be correlated with income. So Janet Curry has this paper about different versions of it. So it just seems like an interesting thing to potentially engage with, of income isn't necessarily unidimensional. And then you ask about these questions of who are the So anyway.
Yeah, and also no, I mean, I love this question, right? Because I think that, like, yes, I've heard that argument so many times. I find it so frustrating because the reality is that for programs that are targeted at like higher income people, we don't do this much work. We don't do anywhere near. We're like, oh, you paid for, you know, like, oh, you're trying to get tax exempt status for this or that, or you're just not paying your taxes. It's fine, you know, right? So first of all, this is like a decision that we've made that's not about efficiency. This is actually about just like I'm gonna call it harassing people. Like, okay, that is what it feels like, because, you know, I some of us have been in these rooms talking to people, and let me tell you, there's a great deal of pain there, and we're just like, you know, trying to like shuffle pennies around and trying to block access to people based off of that. The second thing is what you said, right, which is that it's not like our assistance programs are super robust anyway, right? Like, you know, I just showed you in this very stylized model, you look at income versus like literally you just add one more thing and then it all kind of falls apart. And so I think that says that we should be looking at what, so, you know, you could try to like be more efficient there, or you could try to question, why is it that our budget is fixed? Why is it that every year we're actually spending less and less and less on, say, housing support, right? Right, because that is like one lever that we had accessible to us that wouldn't have caused these like massive trade-offs, where a problem that's formulated in two very reasonable ways actually gives you two different answers and says target group A or target group B. Maybe we should be targeting both groups, right? And so I think just showing this like non-robustness of these problems is something that I feel like we can contribute, right? To kind of maybe ask the harder question of like, maybe we shouldn't be targeting at all. And the third thing I want to say was, I think that the way we do assistance programs in this very like decentralized way is completely inefficient, and I think not really addressing the root of the problem. The reality is that I think if you are, let's say, fed, but you show up to, well, let's say that you're fed, but you don't have access to good education, or vice versa, right? You have access to good education, but you're not fed. Then in some ways, I'm sort of wasting that resource, right? Because you show up to school, but you're not able to pay attention because you haven't had breakfast. And so, I mean, this is just one example, but we know that all of this is happening in one human. Their housing, their education, their health, their everything is happening in one human. And so why don't we also have assistance programs that are aware of this more holistic nature of welfare, right? So that's, I guess, another line of work that we're working on with folks at the California Policy Lab. So yeah, maybe Paul, I'll email you because I think you and I have a lot to discuss.
Okay, thanks so much for the talk. That's great.
There are quite a few questions, so I'll ask both Michael and Daniel to talk one after the other. So Rediet, you can answer both of them.
Sure.
Is it me first? Is it Michael?
Yeah.
Okay. I recently co-authored a paper with someone on basic income, and we were trying to figure out how a basic income might fit into the current social welfare system in the US. And we made a distinction between income support programs and more consumption smoothing or social insurance programs. So income support would be like TANF, or more commonly called welfare, and unemployment insurance would be consumption smoothing. And it sounds to me like, although you're talking about ruin probability as part of poverty, maybe the income support programs address poverty, and ruin probability is more about consumption smoothing and social insurance. So this question may be a lot like the first one. Like maybe, like it's more conceptual. Like maybe it's not really about poverty, but it's more about insurance. And so I'm asking, do you think the distinction really holds? I mean, does that, if you understand my question, is that distinction real, you think, or not really?
Yeah, so great question. So I think that it is also an insurance question, right? So like, I think the way I'm envisioning what you're saying about insurance is that maybe if I experience like a very deep shock, then you kind of buffer that, right? So maybe there's some sort of like relief or some sort of forgiveness that happens. So we are studying that. Actually, we're studying these like saving circles, which I know economists have studied quite extensively. Computer scientists have not. So we're, kind of getting to that. And in particular, looking at programs that we have back home in Ethiopia and other places too, for these for these RASCAs, right, which are a sort of insurance program, right? So the way that we do it in Ethiopia is that if you're part of a saving circle and you go in some order that's determined by a lottery or bidding or whatever, but you are allowed to kind of jump the queue a little bit if you've had some sort of big shock that's happened, like someone passes away and you have to be for their funeral or something, right? So it is also an insurance question, but I think it's also an income support program in the sense that, like, you know, what I'm advocating for here is that maybe we should not be looking at just income. We should be looking at some other measurement of welfare and assisting there. And so if you're imagining that you're above this threshold, this ruin threshold, you might still be needing assistance, right? And so I guess the distinction here is not quite as stark for me, but you know, but I can think about it and I can maybe email you, Michael.
Then Daniel.
Sure, thanks. Thanks for the great talk. I was wondering, you sort of addressed this a little bit in the last few questions actually, but I was wondering if you could say a bit more about your experience in bridging the gap between this optimization work and the policy side. Specifically, how often, if ever, are the social services that you're working with or those agencies trying to optimize something in their allocations? And if so, what would that be?
Yeah, so it's not the only thing they're doing. They're doing a bunch of other things. Bridging the gap has been, it's definitely a lot of work. I'm not anywhere done, you know, near done, but I do think it's actually really exciting work, because I think that folks on the policy side and also working in nonprofits, larger nonprofits, are really excited to talk to people who have the kind of training that we have. And so I found it really exciting to actually just like build shared like language and vocabulary around these things. So there is a lot of like actually targeting and optimization that happens, but often actually there's also sort of like conceptual points that they want to make that we can help with, right? So I think this, like, well, maybe these programs are not super robust to all these different sources of information, was sort of like an idea that came from them, right? And so our job was to sort of try to formalize that and see if that was actually the case. And so there are a lot of like not directly optimization based questions that are also really exciting that come up. Yeah.
So in the interest of time, let's do one more question and then pass it on to Josh.
Yeah, I think there's a question from Tamina.
Sure, go ahead.
Hi, thanks again for the talk. I was wondering if you've done any kind of survival analysis of people who are enrolled in benefits programs. One of the things we've seen a lot in work in graduation programs in developing countries is attrition. And curious to know if this is something you're looking at. Even, you know, despite the best intentions of NGOs, the programs impose hassles over the long term.
Yeah, great question. We haven't, but that is something that I'm definitely keeping in mind. That's a really great question. Yeah. Yeah, right, exactly. So just thinking about like the sort of long-term effects, right? Because a lot of times we make these decisions on like a very short time scale of like a couple weeks, couple months, maybe a year, right? But it's important to actually like think about what happens on a much longer horizon. Yeah, I think that's an incredibly important question, but we haven't yet gotten to it.
Thank you.
Yeah. Awesome. Thank you so much. Thank you. I appreciate it.
Thank you so much, Fred. There's, I think, one more question in the Q&A, but maybe you can answer it in the chat.